case analysis. This method is also similar to the above methods. You will analyze different cases on a number line then to determine your solution. So there's sort of two scenarios that will happen that we'll look at example 6 and 7. So as always, we do need our critical points. So we need our intercepts here. So we will factor to find those. So my x-intercepts are 4 and -2. Now I don't need to draw a number line yet. So this is going to look a little different. We're going to have two cases in each situation. So case 1 we'll look at over here. So for case 1, we're going to look at how can I make a negative number. So this inequality is set, or this left side here is less than 0. So less than 0 means negative. So let's just say negative. There are two possible ways I can get a negative number. I can have a positive number times a negative number, or I can have case 2, which would be a negative number times a positive number. So for example, I could have 2 times -3, or I could have -2 times +3. Both would give me -6. So in case 1, we'll use positive times negative. So I'm going to take the first factor and say it's positive. So that would mean that x minus 4 is greater than 0 is what positive means. And a negative number would be x plus 2 is less than or equal to 0. So this is representing the positive factor. This is representing the negative factor. And now we're going to isolate x. So this would mean x is greater than 4, and this would mean x is less than or equal to -2 in this situation. So I have to draw these on separate number lines. So I'm going to demonstrate x is greater than or equal to 4 on this one. And so we're going to put 0 in the middle, 4 over here, -2 here. I just need those key points. Greater than 4 would mean I would put a point at and it's a solid line, and I would look and shade everything to the right. Okay, to show this on the number line, x is less than or equal to -2. I draw my number line. You want to line up your number lines because you're going to actually do some comparison and overlap. So you want the zeros. You want to line these up perfectly. Okay, so then when I shade x is less than or equal to -2, it's going to be over here. Okay, now I'm going to need case 2 to kind of do some comparing. So let's put a line there. So that case 2 would be if I put the first factor as negative. So that would mean I'm going to go x minus 4 is less than or equal to 0. And my second factor, x plus 2, is going to be positive, so it's going to be greater than or equal to 0. So x is less than or equal to 4, and x is greater than or equal to -2. So we're going to demonstrate both of those on a number line. So we have 0, 4, and -2. So x is less than 4. So I got to go to 4 here. I'm going to shade this. Now I actually want the shading to go past both other critical points, so that, I mean, it continues with an arrowhead, but it's going to stand out a little bit more if you shade that longer. X is greater than or equal to -2, so we draw the number line. Again, the key is lining up the same number line. It's going to help look for overlapping when we get to the next step. So x is greater than -2. Again, I want to actually shade past the other critical point. It'll make this easier. So my solution is going to be where there's some overlap. So in this case, we're just going to say the solution is where the shading overlaps. So for this instance, the overlap happens not in case 1 at all, but over here in case 2. So this part overlapped, right? This is what I mean by the overlap part. So between -2 and 4 occurred in both cases, in both situations on case 2. So my solution then is between -2 and 4. So my solution then is x such that -2 is less than or equal to x, which is less than or equal to 4, where x is the element of all real numbers. Again, your solution sets are either going to be the in-between part or the outside edges.